Now for class 9, this is for class 9, for class 9, force and Newton's law. Newton's law. What is force? Force, it is nothing but it is force, it is push or pull or pull. Force, it is nothing but it is force, it is push or pull. So you may have seen in some door it is written push on one side, and from the inner side it is written as pull. So this is the force. So force are of two types. One is the balanced force, and another it is the unbalanced force, So from this statement it is clear balanced force. That means suppose here there is an object placed on a table. A person applies a force F1 here, and another person applies a force F2 here. So here when your F1 is equal to F2, when this force F1 is equal to F2, that means the body will remain where it is. So this is a balanced force. So this is a balanced force. This is a balanced force. Now suppose same case, this is a block, and here a person applies a force F1 in this direction, and another person applies a force F2 in this direction. If your force F1 is greater than F2, then the block will move in this direction, and this is called unbalanced force. And if your force F2 is greater than F1, then the block will move in this direction. So because here the net force is 0, because here the net force is 0, but here there is a net force. Their net force will exist because F1 is greater than F2, so the body will move in this direction. And if F2 is greater than F1, then the object will move in this direction. Now there was a concept earlier for motion of a body. There was a earlier concept that for motion of a body, an external force is required. External force is required. It was a concept that for a motion, an external force is required. But later on, it was proved that for motion, no external force is required. And for this an experiment was done. That is, two planks were taken, and they were at the same height. Two planks were taken and they were at the same height. So a ball was let to fall from here. The ball would move downward, and again it will rise up to the height from where it falls. The ball was released. No force was given to it. The ball was released. The ball moved downward, and it moved upward to the height from where it falls. So it is the tendency of a ball to move to a height from the height from where it falls. Now the plank was made little bit slanted. So to reach the same height, the ball moved up to this distance. Again, the angle was decreased. So here you see To reach the same height, the ball reached here. So again the plank was made, the angle was again decreased, and here you see, to reach the same height, it has travelled to a distance here. Now, if you make the plank straight, then the ball will move on in search of its height. It will move on. So this motion is called uniform motion. This is called uniform motion. And it proved that no external force is required. For uniform motion, that means the ball will be moving with constant velocity. It will be moving with constant velocity. So this was the concept given. So the earlier it was a concept that for a motion that is an external force is required, but later on it was proved that no external force is required for a body to be in motion, and they proved it, and this motion it was moving with a constant velocity, and here was moving with constant velocity. So from this concept, Newton's three laws came forward. From this concept, Newton's three laws came forward. That is the first law. It is the first law, Newton's first law. Newton's first law. It is also called the law of inertia. It is also called the law of inertia. It is also called the law of inertia. That means if a body is at rest, it will always remain at rest unless and until an external force is applied on it. Similarly, if a body is in motion, it will remain in motion until and unless an external force acts on it. So it is also called the law of inertia. So there are two laws: the inertia of rest, and inertia of motion. So it is the inertia, means it is the tendency of a body. It is the tendency of a body. It is the tendency of a body to remain at rest if it is at rest, and if it is in motion, it remains in motion. So from this, this is the Newton's first law. You may take the example of rest. You may do an experiment. Take a glass and place a cardboard on it. And place a 1 rupee coin here. You strike straight here, the cardboard will move out and the coin will fall down into the glass. This is an example of inertia of rest. Similarly, there are examples of inertia of motion, which happens that when a person, you may find that when you are sitting in a bus, here you are sitting in a bus. So when the bus is at rest, that means the lower part of the body, where your leg is resting on the lower part, it is at rest. That means your whole body is at rest. When the bus starts moving in the forward direction, what happens? Your lower part is in motion in the direction of the bus, but your upper half is still at rest. So you move backward. This is an example of inertia of rest. Similarly, you are seated on a bus. Here you are seated on a bus. The bus is moving. Now when the bus comes to when the bus applies brake and comes to rest, your lower part of the bus, it comes to rest. So here the lower part, that is the leg part, which is in contact with the lower part of the bus, it comes to rest, but your upper part is still in motion, so you move forward. This is the example of inertia of motion. So here you see, this is what Newton's first law. states. Now we come to the Newton's second law. Now we come to the Newton's second law. What is Newton's second law? So here we see the Newton's second law. Newton's second law. Before learning this Newton's second law, we must know the term momentum. Momentum. It is mass into velocity. It is mass into velocity. Momentum, and it is represented as E, and this is equal to mass into velocity. So its SI unit is kg meter per second. This is your SI unit, momentum, mass into velocity. This is your SI unit. Now here, that means, what does this mean? Suppose a bullet, it strikes a wall. So when a bullet strikes a wall, it makes a hole. It makes a hole in the wall. So here two factors, both mass and velocity, are the factors which has created a hole on the wall. It is not only the velocity, but only the mass which has created a hole on the wall. It is the product of these two factors, they together, because of these together, this effect has taken place here. Because of these two factors, the effect has been taken place here. So your second law, Newton's second law, it states that the rate of change of momentum, your rate of change of momentum is proportional to the external force. It is proportional to the external force. This is your Newton's second law. The rate of change of momentum is proportional to the external force. So let us take a body of mass m moving with initial velocity u, and after time t, its final velocity is v. So your change in momentum, that is mv minus mu. This is your change in momentum. This is your change in momentum. Now rate of change of momentum, that means mv minus mu by t. This f is proportional to this rate of change of momentum. So from here, f is equal to some constant k. This is called as proportionality constant. And that is km v minus u by t. And you know that v minus u, that is k, f is equal to k m v minus u by this is acceleration. Now if 1 Newton force is applied on a mass of 1 kg, and the acceleration produced is 1 meter per second square, then the value of k will be equal to 1 and f that will be equal to a. So this is the result we get from the Newton's second law. So here you see that, for example of Newton's second law, when a cricket player catches a ball, it shifts his hand little bit backward. When a cricket player, when it catches a ball which is coming here, catches a ball, it shifts his hand little bit backward to catch the ball. So why do he does this? by increasing the time period, that means by increasing the time period, the force exerted on his hand decreases. That is, by increasing the time period, the force exerted on his hand is decreases, and he can easily, without any harm, he can catch the ball, because here you see F is inversely proportional to T. Now comes our Newton's third law. Here we come our Newton's third law. So what is Newton's third law? Here we come about Newton's third law. The Newton's third law, it is, according to Newton's third law, to every action, there is equal and opposite reaction. To every action there is equal and opposite reaction. According to Newton's third law, to every action there is an equal and opposite reaction. That means let us say recoil of a gun. That means what happens in a recoil of a gun? The coil, it gets compressed. The coil, it gets compressed. Now, when you release this coil, this means in the recoil of a gun, that is the coil present in the gun, it is first compressed. And then when you release this, release the spring, it will strike the bullet. And the bullet will, the spring will act on the bullet. This is action. The spring will act on the bullet. This is the spring. It will act on the bullet. This is your action. And with an equal force, the bullet will act on the spring. This is reaction. And the spring again gets compressed. So this is an example of a recoil. To every action there is equal and opposite reaction, that is recoil of a gun. That means when the spring is at first the spring is compressed, and when you release the spring, it will strike the bullet. This is action, and the bullet with equal and opposite force the bullet will apply on the spring, and the spring will get compressed. So this is all about force and Newton's law.